absolute value graphs are a great graph to introduce you guys to what's called H and K. No matter what function or anything that we wind up graphing in Algebra 2, there's always going to wind up being some, what we call a parent function and a shifted function. So what we do here is we start with a very generic parent function. I'll just grab, just go and send it back, and then I'll just grab it back there in a second. What happens now is we all know what absolute values are. And if I take the absolute value, y equals absolute value of x, and just make a generic table. When I pick values of x, I always pick values that are easy, and usually the values that are bounded across from the y-axis. I pick a couple negative numbers, and I pick 0, and I pick a couple positive numbers. That way I get the layout of what's happening on both sides. It gives it a nice picture. So if I just start at like -3, -2, -1, 0, 1, 2, 3, obviously I'm making more than I normally would, just to give you the idea of what's happening. When I take -3 and for x, I have to do the, well, the absolute value of x is going to generate my value of y to give me my ordered pairs. I know that every single one of you guys have made a table in your lives, and most of this is kind of review. What's the absolute value of -3? What's the absolute value of -2? And so on, and so forth. Okay? That's going to give you ordered pairs. Okay? That'll give you your ordered pairs. Now, what happens then, when you go to start plotting them, you'll notice, let's see here, -3. You have a change of direction. That change of direction winds up being called, for lack of better terms, kind of like the center, the vertex, if you will. The starting point. Okay? It's kind of the starting point. So, where would I say that my center of that graph would be located? At 0, 0. At the origin. I know that I have a center at 0, 0. Also, if you look at it, if I look at just one side of this graph right now, what's the slope of that? It's 1. What's the slope on the other side?
-1.
Boy, that's convenient, isn't it? So the value in front of the x has slopes. One of them is positive and one of them is negative. All of our absolute value graphs mirror this exact same pattern. What changes is where it is located or the slopes. There's some scale factor to them that changes it. So they become skinnier or they become fatter, depending upon how wide they open or what their slopes might be. But every single absolute value graph will always look the same. Now let me ask you this. Do you think it is possible to invert it? Have an absolute value graph that points downward?
No.
What if you did this? Let's go back with the same thing. Y equals, let's say this, -2 times the absolute value of x. If I look at that, I still use the exact same idea of the table figures. I still pick out my values. I'm going to shorten it up just for argument's sake. We'll just say -2, -1, 0, 1, and 2. This tells me when I'm substituting in, take -2 times the absolute value of x to generate my value of y. Well, -2 times the absolute value of -2. -2 times the absolute value of 1. Think about your order of operations. What do you think you have to do first? Yeah. You always do the absolute value first because even though it's not parentheses, it kind of looks like parentheses. It's just a parentheses standing at attention. Yeah, that's that. Okay. So what's the absolute value of negative 2? Well, what's 2 times negative 2? Negative 4. So you go through it this way. Negative 4, negative 2, 0, negative 2, and negative 4. And lo and behold, look what you did to your graph. At negative 2, we were at negative 4. Negative 1, we're at negative 2. Did I just invert the graph?
Yeah.
And I inverted it by multiplying it by a scalar on the outside that was negative. That's all. It still has the same idea. Take a look at your slopes. The slope going to the right, down 2 over 1. Slope is negative 2, isn't it? What do you think that number is going to represent? It's going to represent a slope. That scalar multiplier that you have out in front of the absolute value symbol tends to run itself as a slope. It tells you the direction. It's going to tell you whether or not the graph itself is going to open up or down. Very similar to when you guys did, you guys all took Algebra 1, right? Parabola, right? Remember that, the curve? It was up like a cup, and then it was down like a frown.
For us, it was McDonald's.
I use this. It's up like a cup or down like a frown. It's easier. Same idea. That scalar out in front of the coefficient tells you direction. Positive direction, up like a cup, or up like a V. It sounds good. Or it's down. It opens up or opens down. That A value does that. The other part that we get into then gets into this generic form. This generic form of an equation for an absolute value graph is something you're going to see, this A, H, and K, these values, is something you're going to see over and over and over and over again. We use A, H, and K's for everything. They represent, A is going to represent some sort of a scalar, whether it's opening wider or narrower. Eventually, when we start talking about trigonometry, it talks about the amplitude, how high up a sine graph goes, how compact a cosine graph might be. The H and the K stand for horizontal, H, horizontal, and K, vertical shifts. These H's and K's tell you where these graphs are going to start at when they are shifted. So instead of being shifted or starting at the origin, because it's, when we didn't have anything thrown in there, it was 0, 0, I have these values that I move them to, and then I walk slopes. Or eventually when we start talking about trig, I know how to shift things via a parent function. Yes, ma'am?
What did you say A stand for?
A is, I want you to think of A as more of like an amplitude, and we'll get into each style function that we graph. Obviously today we're just starting with absolute value. The next function that we graph with H's and K's will probably be parabolas. And then instead of H's and K, it'll be with ellipses. And they all mean little bits and things. And every time there's a little thing that kind of means the same, but it's just with a different curve. With these, A is playing the role of a slope for this style, because it's linear. When we got to the curves with parabolas, the A value denoted how wide something opened versus how skinny it opened. Here it's just going to let you see what your slope is, because it's linear. Okay. The vertex is always this value of H and K. You guys used H and K when you did vertices for circles last year, if I'm not mistaken. When you guys wrote out the equation of a circle, where you had parentheses x minus 2 quantity squared plus y plus 3 quantity squared equals 16 in geometry.
Something.
You had the center of the circle was located at 2 and -3 and had a radius of 4.
What was it telling you about your
Oh, I remember now.
teacher?
Time to make a phone call to Seb.
Or you.
I taught you that.
I don't remember it, so you didn't do a great enough job.
So the idea here is that these H's and K's will show you where to start. So if I have a graph, let's say it's y equals 1/2 times the absolute value of x plus 2 minus 3. What I want to do to start this is I want to just figure out, where do I start the graph? Where's the center going to be located and what's its slope? The slope is 1/2. I know the slope is going to be 1/2 because A is 1/2. I know my center is going to be located at H and K. Well, my H and K here is, well, remember, x minus H. So if it's x plus 2, what is the value of H? Minus 2, very good. My center will be at -2, comma, -3. The H and the K's, when it's x minus something, whatever that value is in the equation then, in this case it was x plus 2, it's always the opposite sign. The K value is going to stay the same. Yes, sir?
So if it was x minus 2, it would be 2
Yes.
negative
Yep. You take the opposite value of your H, because x minus a -2 would be x plus 2. And then the other one is just, since it's just plain old boring plus K, it's just that value. That's usually what happens all the time with H's and K's. It's the opposite of H, the same with K. Aside from when you guys did circles, there's a couple other ones, but usually that's how it works. Okay. So if I wanted to take this graph, just with this value,
Yeah. Thanks.
sorry. If I wanted to take this, where do I put my first dot? -2 and -3. And now my slope is 1/2, so is it going to be opening upward or downward? Up. So you walk your slope. You walk your slope 1/2, always go up 1, right 2. Up 1, right 2. And then go the other direction, up 1, left 2. And there's your graph, you're done. Absolute value graphs are ridiculously easy to do. The only kicker is you've got to remember where the H and K goes. That's it. They're that fast once you get going. I like to do this. Yes, sir?
Why is that -2?
It's the opposite. So if you remember, it's x minus H plus K is the generic rule. Since it's minus H and this is plus 2, how do I make this look like minus something? It has to be x minus a -2. That's how it gets to become plus. Okay. I like using this section. It's not a very difficult section to do, but I like using this one a lot because it's a great introduction to H's and K's, H and K. You're going to see it over and over again. Okay? It's a really nice way to get accustomed to it. All right? It takes too much time.
Oh, okay.
What's your A? What's H? And what's K? Label that first when you're doing these, and that'll force you to know what you're doing. So if I have y equals the negative times the absolute value of x plus 2, and then it's plus 3, what's my value of A? It is negative. Since it's a -1, what direction is this going to open? Sometimes it's not a bad idea just to remind yourself, once you know the direction of a graph, it's not a bad idea just to put a little marking on your paper to remind yourself, hey, I got to make sure this opens downward, so you don't make a bonehead move. I see it over and over again. Students will label out everything correctly. They just go the wrong direction. because they're so used to doing something the same way. Instead of saying, just mark it, saying, oh, don't forget this, you bozo. What's H? And K? So where's your center? Good. So you start at -2 and 3. And I walk my slope. When I walk my slope, I'm always going to walk it like I would down and right or up and right first, and then I mirror it on the other side. Because they're symmetrical. Right? They are symmetrical to one another. Down one, right one. Down one, right one. The opposite, well, the symmetrical one would be down and left. And lo and behold, you've got an absolute value graph.
Can I just like stop at any point, basically?
Yeah, when you're plotting these things through, if you do 3 or 4 of them, it's pretty straightforward.
Okay.
You don't need to go
Yeah.
crazy on them.
Thanks.
The main idea is here, can you identify, yes. Can you identify where your A, H's, and K are going to wind up? Can you identify what your slope's going to wind up being and get a rough sketch of what it's going to look like? And if you can do that, you're going to be just fine. Yay, math. Let's see if I can make this more difficult. Let's see if we can figure out what the equation is. You guys see that all right? Might not be.
Give me a second. I'm gonna need like lots of time.
Group this up for a second. So I can move this over. Oh, it's not going by 5. It's they're ones. It's just a marker at 5, at 10. That's all.
Okay.
So if I'm looking at that, the first thing you always want to try and do is always identify your H and K. Where's the center located at? 3, 1. Yeah, it's at 3 and 1. So the center's at 3 and 1. So that's H. That's K. Is it opening upward or downward?
Downward.
Downward. So your A value is going to have to be what? Negative. Good. So A is going to be a negative. Well, we just got to walk our slope. All right. 1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. So what's down 3, right 3? 1. So now you have your A, H, and K. You fill in the blanks to write out the equation. So when you do that,
Slope is 3. Oh, I see.
that's it.
Yeah, I got it.
It's easier to do than those piecewise
Yeah.
because you have only one spot to worry about, as to worry about different domain restrictions. Here you don't have to worry about it. It's exciting. That's it. Try this one. Invert this one here so you can see it. It doesn't nicer. It doesn't distort as badly as it used to. Hey, we're getting fancy around here, ladies and gentlemen. We're getting fancy.
Wow.
Where's your center? -1, -1? Slope? So that means y equals a absolute value x minus h plus k. When you substitute in, what's your final result?
2. Okay. It's so too much. No, yeah.
Math!
Woo!
It's easy.
This is fun.
What's wrong with it? What's wrong?
I would cry too.
People are crying over here.
Aw.
It's gonna be crazy.
What did you do to them?
Math!
You should be disappointed.
I only have a few of these to do tonight, so.
Yeah.
It was more of an intro for the idea of A, H, and K, because we use it so much more later.
It's still a nice phrase. It's over.
So let's do this. This is 2.8. Mine's it being 126.
We got a question for you.
What do you got?
Do you bust out your worksheets in this class too?
Sometimes. Not as often.
Oh, dang. 'Cause
Not as often.
those were really helpful because I only had to carry my binder, not my book.
So you've got 4 of them you'll graph, and then the other 6 you're just writing the equation. Four of them to graph, the other 6 to write the equation. Very, very, very straightforward.
I knocked these over today.
What's that?
I knocked those over. I know.